Hello, everyone. Thanks for watching this video. This video will discuss our work EKD, an evaluation-oriented knowledge distillation method for deep face recognition. We will release our codes at this address. With many recognition systems deployed on mobile and edge devices, compact yet discriminative models are in increasingly high demand. Since the parameter of the compact models is far less than the large models deployed in GPUs, there exists an enormous performance gap between the two types of models. The knowledge distillation method is a widely used technique to improve the performance of compact models. Commonly, the big and deep models are used as the teacher models, and the small and shallow models are used as the student models. They are often trained with the same dataset, and the knowledge from the pre-trained teacher model is transferred to the student model during training. Previous KD methods mainly fall into two categories: instance-based methods and relation-based methods. Instance-based methods transfer individual outputs from a teacher model to a student model pointwise. Relation-based methods improve the instance-based KD method by transferring relations of the samples in a batch. However, it is still far from perfect as these methods have two strict constraints on knowledge transfer. Instance-based methods require the teacher and student to share the same representation space, while relation-based methods require the student to mimic all relations between samples in a mini-batch. In face recognition, taking the similarity as the relation, the key knowledge is the relation between the similarity and a chosen threshold. As shown in the figure, if the thresholds roughly correspond to FPR equals 1e-5 or 0.55, the relation of the first and the third samples is the only one whose similarities fall on the different side of the threshold in teacher and student models, and thus leads to the TPR difference. Therefore, to pursue the same TPR as the teacher, the student should pay more attention to the relation of the first and the third samples. Thus, we propose an evaluation-oriented knowledge distillation (EKD) method for deep face recognition, which reduces the performance gap between the teacher and student models. In our method, the critical relations are defined as the relations that cause the TPR and FPR difference between the teacher and student models. Based on the TPR and FPR calculation, the critical relation condition can be formulated as this equation. The equation means the similarities of the corresponding pairs on the different sides of the thresholds in the teacher and student models. And our goal is to require the similarities on the same side of the thresholds. Since the indicator function is a step function whose value is 0 or 1 and the thresholds are monotonic, the loss can be formulated as this equation. However, the indicator function cannot be optimized with gradient-based methods. A sigmoid function is used to approximate the indicator function. As shown in the ablation study on the effects of the temperature tau in the sigmoid function, a suitable t that equals 0.01 gives a good approximation to the indicator function and provides appropriate gradients. The figure on the right shows the ratios between the number of critical relations and total relations during training in the baseline and our method. The number of critical relations trained by our method is smaller than the baseline, demonstrating that our approach does reduce the performance gap between the teacher and student models during training. We also conduct extensive ablation studies on student network structure, hard negative mining strategy, threshold number, and loss function, demonstrating the effectiveness and generality of our method. We compare with a wide variety of SOTA KD methods, including the methods proposed for other tasks and specifically designed methods for face recognition. Our method achieves the best average performance on these test sets except for the top 1 performance on megaface. The reason may be that our method adopts the TPR and FPR as the performance indicator during training and overlooks the top 1 performance. In summary, we propose a novel evaluation-oriented KD method for deep face recognition. In subsequent work, we can try to improve the TOP1 performance of our method with more suitable performance evaluation metrics.